Question 3. This was a question where a lot of students were not able to get the full marks. It says a particle P of mass 4 kg is at rest at the point A on a smooth horizontal plane. At time t is equal to 0, 2 forces F1, which is 4I minus j newtons, and F2, which is lambda I minus mu j newtons, where lambda and mu are constants, are applied to P. Given that P moves in the direction of the vector 3I plus j, show that lambda minus 3 mu plus 7 is equal to 0. So particle P is moving in the direction 3I, which is the x, and j, which is the y, which means that the I component is 3 times bigger than the j component. And if we now use F1 and F2 to find the resultant force, we can just add them up. F1 is 4I and j is minus 1. F2 is lambda for the I and mu for the j, and if we add these, this gives 4 plus lambda for the I and minus 1 plus mu for the j. Because we know that the I component should be 3 times more than the j component, this means that the I component which we have found, 4 plus lambda, should be 3 times bigger than the j component, which is minus 1 plus mu. And we can now expand the brackets to give us 4 plus lambda is equal to minus 3 plus 3 mu. And because the question is asking us to show it in the form where everything is equal to 0, if we move everything onto the left-hand side, we can first add 3 to the 4, which gives us 7. We've then got the lambda, and then if we take away the 3 mu, this gives minus 3 mu, and this is all equal to 0. And we can just rearrange it to give it in the form that they want, which is putting lambda first, then the minus 3 mu, and then the plus 7. And we have now shown this as was required. The next part says, at time t is equal to 4 seconds, P passes through point B. Given that lambda is equal to 2, part A, find the length of AB. So now that we know that lambda is equal to 2, we can substitute lambda into the equation that we've got. So when lambda is equal to 2, we can substitute 2 minus 3 mu plus 7 is equal to 0. So 2 plus 7 gives us 9. So we have minus 3 mu plus 9 is equal to 0. And if we now move the 9, we will have minus 3 mu is equal to minus 9, which means that mu is equal to 3. Now that we know mu and lambda, we can now find the resultant force, or the total force, by substituting it into what we got in part A. So if we just do 4 plus the lambda, which is 2, and minus 1 plus the mu, which we found to be 3, this gives us 6 and 2. So because the question is asking to find the length of AB, that means we are looking for the distance between the point A, where it started, and point B, which is where it is after 4 seconds, which means we can now use SUVAT to help us find this displacement. The initial velocity is going to be 0. We don't know the final velocity. We can find the acceleration, and t is equal to 4. Because the particle is accelerating, we can use the formula force is equal to mass times acceleration to find the acceleration. We now know the resultant force is 6 and 2. The mass of the particle is 4, and we are looking for A. So we can divide these vectors by 4 to get A. So 6 divided by 4 is 1.5, and 2 divided by 4 is 0.5, and this is the vector for acceleration. So to find what the length is of AB, we can first find the displacement and then use this to find the length. And using the SUVAT formula, which are given in the formula booklet, we will be using S is equal to UT plus a half AT squared. So we can put S, and because the initial velocity is 0, this whole part becomes 0, and therefore we can just substitute the A, which is 1.5 and 0.5, and the T, which would be 4, and this is squared. So we know that 4 squared is 16, and if we halve 16, that gives 8. So we are multiplying 8 by 1.5 and 0.5, and this then gives us 12 and 4. So the displacement that we got is 12 and 4. However, because the question is asking for the length of AB, this means we are now going to use the displacement to find the distance, and we can now just square the I component, which is 12, the j component, which is 4, and then find the square root, and that gives us 4 root 10 meters.